Okay, why do we need limit of a function? So, doon sa mga nakapagturo na or sa nakuha na to sa school, ang naalaala nyo, anong nasabi or na-feeling nyo? Definitely, you've encountered limit, okay, in your calculus course, in your college. So, mga nagsisimula pa lang na estudyante ngayon, when you took calculus, definitely already encountered limit. Ano naalaala ninyo? Saan ginagamit ang limit ang limit of a function? What is its role in the study of calculus? Anyone? Again, you can use the chat. Ang naalaala ninyo? Hindi nyo madi-deny because as far as I know, lahat ng curriculum ng calculus or syllabus in calculus, lagi siya nagsisimula with a bits of limits and continuity. So that's why I'm asking you now, sa encounters niyo with calculus, kasama nyo rito yung mga estudyante pala nagsisimula ngayon ng kanilang calculus journey, saan daw ginamit, bakit natin kailangan ang limits in the study of calculus? Anyone? Oh, hello, good morning. Oh, bakit daw kailangan natin ng limits sa calculus? Hello po. Ayan.
Excuse me, sir.
Yes, sino po nagsasalita?
Ako po si Aris Gayo po, sir.
Yes, sir.
By the way, I already took up the kaning calculus po sa college. Hindi ko na po talaga siya na parang meron akong maliit na stock knowledge po dito, pero based sa limit of a function, kailangan po natin yung limits para po meron tayong basihan or ceiling sa pag-solve ng mga equation. Kasi pag wala tayong limits, parang hindi natin makuha yung exact. Parang ganun po yung understanding ko po. Thank you, sir.
Okay, sir, it's some sort of a ceiling or a boundary. But we can think of it as a boundary in some sense, but then as you will see, limit is not really about a boundary or a ceiling or coming up with some boundaries. It's more really on, as we will see in a while, it's more on focus on the behavior of functions. Limit is, yun ang kailangan natin pag-ingatin dito. Because usually, pag sinabi kasi natin limit in a usual sense, sa casual discussions natin, pag may kausap tayo, pag sabi mong limit, parang boundary. Parang yan ang limit mo, hanggang dyan ka lang. But as we will see, it's not really the idea of a limit when it comes to limit of a function. You can interpret it as some sort of boundary, but it's not really the boundary. Kumbaga, it's really more on observing a behavior of a function. But then going back to my question a while ago, saan nyo ba ginagamit ang limits and continuity? So Rensemer in the chat mentioned limits are used to define derivatives and integrals. And yeah, that is one primary reason why you need limits in calculus. Derivatives and integrals are defined in terms of limits. Mamaya ko balikan yung ibang chat ha. Let me show you. This is the definition of a derivative. This will not be covered today. This is on the second Saturday next week. Okay, and look at that. Formally, the derivative of a function is defined this way. It is the limit of the slope of a secant line. Kumbaga, ito kasi expression na to, gx minus gb over x minus b is considered as this one is considered as nakita niyo naman po yung cursor ko na nag-move across the screen. Tama po ba? Hindi ko alam kasi kung naka-point ako sa tamang lugar. Okay, thank you. This is considered as a slope of a secant line. Remember, di ba pag slope, y2 minus y1 over x2 minus x1. So this is a slope of a secant line. And when you talk of a derivative, it is the limit of a slope of a secant line that can be interpreted also as a slope of a tangent line. Again, this is not for today, okay? This will be for the second day. But then let me tell you now that when you talk of limits, why do we need to start with limits? Because derivatives are defined in terms of limits. I know sabihin niyo, di ba may mga derivative formula na naman tayo, power rule, product rule, quotient rule, but then in essence, you have to go back to how they are formally defined rigorously. And for the case of derivative, the limit of a slope of a secant line. So derivative is defined in terms of limit, not only derivatives, but also integrals. Integrals, in particular, definite integral is the limit of a so-called Riemann sum. Again, this will not be covered today, but this will be for the third day. But then let me tell you now that when you talk of definite integrals or integrals, it is a limit of a Riemann sum. Okay? So that is one primary reason why we need the study of limits and continuity, because because derivatives and integrals are defined in terms of limits. Okay? But not only that, someone mentioned in the chat, behavior of a function at a certain point. Yes, Ronald Gigante, thank you for that answer. Yeah, definitely when you're going to integral, you need to determine area of a curve to understand behavior. Yeah, nagmula yung derivatives. Okay, so at least you have some notion that really these derivatives and integrals are formally defined in terms of, not that, in terms of limits, this one, and then this one. But then going beyond derivatives and integrals, in its own way, mahalaga rin ang pag-study ng limits. Some of you already mentioned behavior of functions. Because you can really use limits to study behavior or trends in functions. I'm showing you two classic graphs in. Today we're just going to cover more on the algebraic functions. But then in this case, kailangan ko just to show you, let's say this function on the left side, the graph of y equal to sine x over x. Okay, notice sine x over x, this is undefined at 0. Diba? At x is equal to 0, the denominator will be 0. So this is really undefined at 0. But then look at the behavior its graph. Even if it's undefined at 0, look at that. Kumbaga undefined siya dito, notice there is a hole. But then at the rest, you can find the graph of sine x over x, y equal to sine x over x. But then using limits, it can provide you an idea the behavior of the function around x equal to 0. Kumbaga, if you're going to trace the graph, going to x equal to 0, you can observe some behavior. And limits can provide us an explanation why there is this behavior. And also over the right-hand side, ito naman yung graph ng y equal to sine over 1 over x. Look at that. Going to x equal to 0, nagkakaroon sila ng mga oscillations. Actually, heavy nga yung oscillations. Kumbaga, at the start, medyo magkakala yung oscillation. But then as you go to x equal to 0, nagiging highly oscillating yung function natin. But then, of course, the question is, what will be the behavior of the function? And limits can answer that. And along in our discussion today, you're also going to observe some examples on how really you can use limits to study, let's say, this function. What will be the behavior of the function as t increases without bound? Also for the same case on this graph on the right side. Or this one. Okay? I'm just giving you an overview of the things that you'll encounter later today, okay? Baka kasi iba nabibilisan sa inyo. Again, this is just the introduction. This is the graph of 1 over x minus 2 squared. Okay, sasabihin sa atin, meron siyang asymptote at x equal to 2. Tandaan natin, di ba? Vertical asymptote. This is an example of a rational function undefined at x equal to 2. And specifically at x equal to 2, it will have a vertical asymptote. But then the question is, bakit nga ba siya nagkaroon ng vertical asymptote? Di ba? Bakit siya nagkaroon ng vertical asymptote sa x equal to 2? So usual textbook will tell us, dapat meron siyang vertical asymptote because it is a rational function. Pero the question is, bakit nga ba meron? And actually, limits can provide us an answer. As we will see later, it will really show us that as the values of x approaches x equal to 2, there will be this asymptotic behavior. But then more of that later once we go to limits involving infinity. Okay, so two things again. We need limits and continuity to formally define derivatives and integrals. And then next, in its own, you can use limits and continuity to study behaviors of functions. Okay? So at least some of you siguro medyo na-refresh na, especially to those na medyo matagal na naka-encounter ng limits and continuity. But then definitely, when you started your calculus journey, it started really with limits and continuity. Okay? As far as I know, from all curriculum, hindi kaagad kayo, ito yung formula ng derivatives, ito yung formula ng integrals. No, you start with limits and continuity to give you the general idea, the formal definition of what we mean by derivatives and integrals. As I showed you, they are defined in terms of limits.